Somewhere in the depths of cosmic darkness, there is an object in which matter itself loses its usual outlines, and space ceases to behave as something stable, where light doesn't just disappear, but ceases to exist as a process. A giant center of gravity known as TON 618 rotates. Its mass is so colossal that the usual scale of stellar systems ceases to matter, and the orbits of light and gas are subject exclusively to the curvature of space-time. Around this object is the active nucleus of the quasar, where matter does not fall instantaneously, but swirls into a giant accretion disk. This disk is not a stable structure in the usual sense.
It is constantly changing, heating up to temperatures at which atoms lose their integrity, turning into a stream of charged particles. The inner regions of the disk move at tremendous speeds, approaching the limit set by the very nature of space. At the same time, the energy released in the process of falling matter exceeds the luminosity of entire galaxies. Gravity at the center is so powerful that even a photon born near the event horizon loses its chance of escaping. Space there is curved so much that the direction inward becomes the only possible path of movement. And the closer to the center, the stronger the gradient of this curvature becomes, turning the area around the core into a dynamic system, where each particle of matter obeys not local laws of motion, but the general geometry of space.
The accretion disk around TON 618 emits radiation that spans the entire electromagnetic spectrum. X-ray and ultraviolet fluxes form in the hottest inner layers, while cooler outer regions emit in the optical and infrared ranges. This makes the quasar one of the brightest sources of energy in the universe, despite the fact that the black hole itself does not emit light. Near the event horizon, space acquires properties in which time begins to flow differently from more distant regions. The streams of matter approaching the center are slowed down from the point of view of external observation, but at the same time, for matter itself, the process of falling is continuous. This paradoxical effect is created by the curvature of time, which becomes part of the gravitational field. The size of TON 618 is striking even on the scale of supermassive objects. Its mass is estimated to be in the tens of billions of solar masses, making it one of the largest known objects of its type. The radius of the event horizon extends over hundreds of astronomical units, covering a space comparable to the scale of entire planetary systems. Within this region, any structures become unstable as gravitational forces dominate all other interactions. The gas falling into the center forms complex spiral structures where shock waves and magnetic fields intertwine in a continuous process of energy redistribution. Magnetic lines twisted by the rotation of the disk accelerate particles to relativistic speeds, creating powerful jets of plasma that can be ejected far beyond the galactic core. These jets break through the surrounding space, spreading energy over huge distances. On these scales, matter behaves not like individual atoms, but like a continuous medium in which density, temperature, and pressure change smoothly but extremely. The inner regions of the accretion disk become a source of instability, where the slightest fluctuations are amplified by gravity and magnetic fields, creating turbulent structures that exist in constant dynamics. The black hole itself does not have a surface in the usual sense. The event horizon is not a solid boundary, but a mathematical surface separating the region from which it is impossible to return from the rest of the universe. Everything that crosses this boundary becomes part of the internal structure, information about which is inaccessible to external space. Light passing near TON 618 experiences strong gravitational lensing. Its trajectories are curved, creating multiple images of distant objects. This curvature is not a local effect, but manifests itself as a result of the general geometry of space, distorted by a colossal mass. In some cases, light can bend around an object several times before leaving the area of influence. The energy released during the accretion process is not evenly distributed. It is concentrated in certain zones of the disk, where the density of matter reaches critical values. These zones become sources of flares that can last from hours to millions of years on cosmic scales. Each such flash reflects a local restructuring of matter flows near the center. A black hole of this magnitude affects not only its immediate surroundings, but also the dynamics of the entire galactic environment. Gas clouds thousands of light-years away can gradually become unstable under the influence of gravitational perturbations that direct matter toward the center. This creates a long-term process of mass growth in which the galaxy and its nucleus are linked by a single mechanism of matter exchange.
Temperatures near the inner regions of the accretion disk reach millions of degrees. Under such conditions, atomic nuclei encounter energies sufficient to break the habitual bonds. Matter becomes completely ionized, turning into plasma, where the interaction of particles is determined by electromagnetic and gravitational forces at the same time. With increasing depth in the gravitational field, the speed of rotation of matter increases, and the disk acquires a flat but extremely dense structure. The outer layers move more slowly, while the inner layers almost reach relativistic limits. This creates differential rotation, which strengthens the magnetic fields and maintains a steady energy activity of the system.
TON 618 is not a static object. Its mass gradually increases due to the absorption of the surrounding matter. This process can last billions of years, during which the structure of the galactic nucleus is constantly changing. At moments of increased activity, the quasar becomes especially bright, surpassing entire clusters of stars in luminosity. Radiation emanating from the center interacts with the interstellar medium, heating and ionizing gas clouds. This leads to the formation of regions where star formation is suppressed, as matter cannot be effectively compressed by its own gravity. Thus, the central object influences the evolution of the entire galaxy by regulating the birth of new stars.
Gravitational effects near the event horizon become so strong that the classical description of motion is no longer sufficient. Space and time cease to be independent entities and form a single dynamic continuum in which the movement of matter is determined by the curvature of the very structure of reality. Even at a distance where the influence seems weak, traces of the presence of such an object are evident through the behavior of the gas, the distribution of stars, and the shape of orbital structures. Everything around is subordinated to an invisible but extremely powerful central point where mass is concentrated that can change the geometry of the surrounding space.
TON 618 remains one of the most extreme manifestations of gravity in the universe, where matter, energy, and space form a system beyond the usual scale of understanding cosmic processes.
The streams of matter that continue to fall into the depths of the gravity well of TON 618 do not disappear instantly at a single point, but go through a complex sequence of transformations, where each stage is accompanied by a change in the structure of energy and space. As you get closer to the center, the density of radiation increases so much that the very motion of the photons becomes part of the overall dynamics of the system, creating regions where light is actually locked in orbital trajectories, orbiting around the void that defines everything around it.
The inner zones of the accretion disk become an arena of constant redistribution of momentum. Particles collide not as separate objects, but as a continuous plasma medium where magnetic field oscillations form complex wave structures. These structures can exist only under conditions of extreme gravity, since any weakening of the field destroys their integrity and leads to disintegration into simpler configurations. The closer the matter is to the event horizon, the stronger the effect of slowing down processes relative to outer space. Energy transitions begin to stretch, turning into long cascades of radiation. At the same time, locally for matter itself, the motion remains continuous, and no slowdown is felt in its own frame of reference, which creates a fundamental difference between the internal and external pictures of what is happening. The gravitational field is so intense that it begins to affect the very geometry of time flows, forming regions where cause and effect relationships acquire a complex structure. Under these conditions, the trajectories of motion of matter are no longer determined only by the initial velocity and direction, but depend on the general configuration of spacetime, which itself changes under the influence of mass. Powerful relativistic jets that arise in the polar regions are formed as a result of the interaction of a rotating disk and a magnetic field swirling around the center. These jets eject plasma at a colossal speed, approaching the speed of light, and are able to cross intergalactic distances while maintaining the structure of a directed flow. Their energy is so great that they become one of the key factors influencing the space environment. Inside these jets, matter is in a state where particles are accelerated to extreme energies, and magnetic lines form a guiding framework that keeps the flow from dissipating. Any deviation is compensated for by an instantaneous rearrangement of the field, making these structures among the most stable dynamic phenomena in the cosmos, despite their extreme energy characteristics. The accretion disk continues to accumulate matter from the surrounding space, gradually increasing the total mass of the central object. This process is not uniform. Periods of relative calm are replaced by phases of high activity, when the influx of matter increases sharply. At such moments, the luminosity of the system increases, and the quasar becomes the dominant source of energy in its cosmic environment. Gas clouds located at a considerable distance can gradually lose their structure under the influence of radiation and gravitational perturbations. Their density is redistributed, forming elongated streams of matter that are directed towards the central region. In this way, a long-term feeding mechanism is formed, in which the environment becomes part of a single system of energy and mass exchange. Near the center, there are zones where energy is so concentrated that there is a continuous production and annihilation of particles. These processes create fluctuations that increase in the magnetic field and lead to the appearance of flares of varying duration. Each such flash reflects a local rearrangement of matter flows and a change in the configuration of the disk. The gravitational lensing created by the mass of the central object distorts the propagation pathways of radiation coming from more distant regions of space. Light
passing through curved space can be deflected repeatedly, forming complex trajectories that create multiple images of background sources. This makes the surrounding space visually and physically altered at great distances from the very center.
Over time, the structure of the accretion disk changes. The inner regions gradually lose stability due to extreme energies, while the outer ones continue to supply matter inside. This creates a constant density and temperature gradient, maintaining the dynamic equilibrium of the system, which never comes to rest. In the depths of this process, space becomes increasingly curved until it reaches a limit beyond which the classical description ceases to be applicable. Under these conditions, matter, energy, and the geometry of space form a single system in which every change in mass is immediately reflected in the structure of the surrounding reality. Even at a considerable distance from the center, traces of this activity remain visible. The distribution of interstellar gas, the shape of orbital motions, and the nature of energy flows bear the imprint of the presence of a giant gravitational source. The entire space around becomes part of a large-scale interaction in which a central point determines the dynamics of huge regions of the galactic environment. And as this process continues, the system is not nearing completion, but only deepening its complexity, expanding its area of influence, and strengthening the internal energy flows that continue to form the cosmic structure around itself. Deeper in the structure of this cosmic stream, TON 618, a process continues in which the boundaries between radiation, matter, and the geometry of space itself become increasingly indistinguishable. The energy passing through the accretion disk is no longer distributed as separate pulses, but forms a continuous field of oscillations, where each point is connected to the others through gravitational and magnetic interactions. The inner layers of the disk begin to exhibit behavior in which stable orbits no longer exist in their usual form. Instead, time trajectories are formed, constantly changing under the influence of the increasing curvature of space-time. These trajectories do not persist longer than required for the next redistribution of energy, after which they disappear and reappear in a new configuration. Temperature gradients in these regions reach such values that the difference between different states of matter becomes conditional. Plasma ceases to have a stable structure, passing into a continuous rearrangement mode where particle collisions create cascades of secondary interactions. These cascades form a complex network of energy flows that permeate the disk from the outer boundaries to the innermost regions. The magnetic fields, twisted by the rotation of the central mass, are amplified by the constant compression and movement of the ionized gas. Their lines are stretched, curved, and torn apart to reconnect in new configurations. In these processes, powerful pulses of energy are released, which propagate along the axis of rotation, forming stable directional ejections of matter. Relativistic jets continue their movement beyond the gravitational influence of the central object. They traverse the surrounding space with a high degree of directionality, maintaining the structure specified by the formation conditions near the nucleus. As you move away from the center, the density of the stream decreases, but its energy structure remains noticeable at great distances. In the vicinity of the core, intensive absorption of matter coming from the outer regions continues. Gas streams that become unstable under the influence of radiation and gravitational perturbations are gradually directed towards the central region, where their movement accelerates. This process creates a continuous cycle of mass redistribution that keeps the system active. The radiation resulting from the fall of matter
interacts with the environment, creating ionization zones where the atomic structures are completely destroyed. These zones extend over considerable distances, forming regions in which the interstellar medium acquires new physical properties. The gas in such regions becomes less capable of compression, which changes the dynamics of further star formation. The gravitational field of the central object continues to change the trajectories of movement, not only of matter, but also of the radiation itself. Light fluxes passing near the region of maximum curvature can repeatedly change direction, creating complex loop-like propagation patterns. These effects become especially pronounced near the event horizon, where the geometry of space reaches the limit values of curvature. The inner realm continues to be inaccessible to any external interaction. Everything that crosses the critical boundary ceases to participate in the further evolution of the external environment and becomes part of the internal structure, inaccessible to observation. This boundary is not a physical surface, but is the region where the direction of all possible trajectories becomes inward. Over time, the accretion process does not slow down, but remains dynamic due to the balance between the influx of matter and the release of energy. This system is self-sustaining through the interaction of gravity, radiation, and magnetic fields, forming a stable but constantly changing cosmic mechanism. And as this evolution continues, the central region retains its role as a source of extreme processes, where matter, passing through various states, becomes part of a structure in which the boundaries between form, energy, and space finally lose their distinguishability. As we delve further into the structure of TON 618, it becomes increasingly clear that the central region is not just a point of maximum density, but is a dynamic system in which causality itself manifests itself in a distorted form. The flows of matter that cross the inner boundaries of the accretion disk no longer maintain continuity in the classical sense. Their state is determined by continuous rearrangement under the influence of the extreme curvature of spacetime. The inner orbits of matter begin to lose stability, not gradually, but cascading. Every slightest disturbance is so amplified that the structure of motion breaks up into a series of short-term configurations that exist only within the limits of local energy conditions.
These configurations disappear as quickly as they appear, leaving behind only traces in the form of redistributed radiation and altered magnetic lines. In the accretion disk, the process of intense heating continues, in which the energy of the gravitational fall is converted into radiation covering a huge range of wavelengths. In the densest regions, plasma reaches a state in which electromagnetic interactions become the dominant factor in the structure of matter, and gravity sets the general framework of motion. This creates conditions under which matter exists in a regime of constant energy tension.
The magnetic fields that penetrate the disk begin to form complex, self-sustaining structures. Their lines do not just follow the movement of the plasma, but actively affect its distribution, creating zones of concentration and rarefaction. In these zones, local particle accelerations occur, leading to the formation of high-energy flares that can propagate throughout the disk in the form of rearrangement waves. The relativistic jets that form along the axis of rotation become even more stable as they move away from the central region. Their structure is fixed by a magnetic framework that keeps the flow from dissipating even over huge distances.
These jets carry energy formed near the event horizon and carry it into intergalactic space, affecting the environment on scales comparable to entire galaxy clusters.
Gas clouds located in more distant regions continue to be affected by radiation and gravitational perturbations. Their structure is gradually rebuilt, forming elongated threads and flows that are directed towards the central object. This process creates a long cycle of redistribution of matter, in which the external environment becomes a source of nourishment for internal activity.
In the region approaching the event horizon, space acquires a character in which all possible trajectories of movement are directed inward. Here, the possibility of stable existence of orbital structures disappears, since any form of motion inevitably leads to the crossing of a critical boundary. This boundary does not separate space physically, but defines a fundamental difference in the behavior of all processes. Light passing near this region is so strongly bent that its trajectories begin to form closed loops. These loops can exist for long time intervals, repeatedly circling the central mass before leaving the area of influence or disappearing behind the event horizon. This behavior reflects the extreme degree of interaction of radiation with the gravitational field.
The inner layers continue to absorb matter without a visible saturation limit. The more mass accumulates, the stronger the gravitational field becomes, and the more effective the process of further attraction turns out to be. This creates a self-reinforcing mechanism in which the growth of the central object supports the conditions for even more intense growth. At the same time, the system remains stable due to the balance between the influx of matter and the release of energy through radiation and jets. This balance is not static, but is a continuously fluctuating state in which the parameters of the system are constantly shifting, but do not go beyond the limits of stable dynamics.
And as this process continues, the central region remains the place where the familiar concepts of matter and space lose their applicability, and the whole system continues to exist as a single, constantly evolving cosmic mechanism. The longer TON 618 continues to exist, the deeper its influence penetrates into the surrounding space environment. Huge volumes of gas, located far beyond the central core, are gradually involved in the general motion, forming giant streams of matter directed towards the region of maximum gravitational curvature. These flows do not move chaotically, but are subject to the complex structure of the field created by the rotation and mass of the central object. At enormous distances, the radiation of the quasar continues to change the state of the intergalactic medium. Streams of ultraviolet and X-ray radiation ionize gas clouds, destroying neutral atomic structures and turning the surrounding space into an area of high-energy activity. Under such conditions, the temperature of the medium increases so much that many processes of formation of dense gas accumulations become unstable. The inner accretion disk continues to rotate at a tremendous speed. Its outer regions remain comparatively colder, but as it approaches the center, the temperature rises like an avalanche. The difference in velocities between adjacent layers creates the strongest friction inside the plasma, and it is this friction that becomes one of the main sources of energy that feeds the luminosity of the quasar. In the hottest regions, an intense interaction between photons and charged particles begins. The radiation becomes so dense that it itself begins to affect the movement of matter, creating radiation pressure directed outward. However, even this energy is not able to completely stop the fall of matter, since the gravity of the central object remains the dominant force of the entire system.
Magnetic fields continue to increase as the plasma swirls. They form a complex multi-layered structure in which individual field lines intertwine and periodically tear apart, releasing huge amounts of energy. These processes resemble giant magnetic flares, but their scale exceeds anything observed in ordinary star systems. Along the polar directions, the emission of relativistic plasma continues. The jets remain narrow and stable thanks to a powerful magnetic framework that keeps the particles inside the stream. The velocities of matter in these jets are so high that even after great distances, they retain their direction and energy, spreading the influence of the central nucleus far beyond the galaxy. The outer regions of the quasar gradually respond to this activity. Gas structures are deformed, orbital motions become less stable, and dense clouds of matter begin to stretch into long filaments under the influence of tidal forces. These forces arise from the difference in gravitational influence on different parts of the clouds and become more destructive as you approach the center. The space around the event horizon remains one of the most extreme regions in the universe. Here, the curvature reaches such a degree that even the direction of time acquires a special character. All possible paths of movement lead inward, and the very structure of space begins to function as a flow directed towards the central region. At the boundary of the photon sphere, light can move in closed orbits, repeatedly circling the black hole. These orbits are highly unstable. The slightest change in trajectory either ejects a photon outward or sends it beyond the event horizon. However, it is in this region that some of the most complex gravitational lensing effects are formed, creating distorted images of distant light sources. The substance that crosses the inner regions of the disk gradually loses its distinguishability as a separate structure. The pressure, temperature, and gravitational forces become so enormous that the usual states of matter cease to exist. The plasma turns into a super-dense flow of energy and particles, the motion of which is determined solely by the geometry of space-time. Even after billions of years of activity, the system is not approaching a state of rest. As long as there is an influx of matter, the quasar continues to radiate enormous amounts of energy, maintaining a continuous cycle of accretion, ejection, and gravitational interaction. The mass of the central object slowly increases, increasing its influence on the surrounding space and changing the structure of the galactic environment around it. And in the depths of this continuous dynamic, there remains a region hidden behind the event horizon, where all known processes cease to be observable. There, the possibility of receiving information from the external universe ends, and space passes into a state in which the laws of motion and time become part of a single, inaccessible structure. And the longer the existence of TON 618 continues, the more clearly its role as a center of continuous cosmic restructuring is manifested. The matter that still exists in the vicinity of this giant no longer forms the usual clouds or stable structures, but exists as a stream that is constantly changing shape under the influence of gravity, radiation, and magnetic fields. The accretion disk continues to be one of the most energetic objects in the universe. Its inner region is almost completely devoid of stable states of matter. Each collision of particles redistributes energy so quickly that a continuous cascade of microscopic interactions is formed, which add up to a macroscopic flux of radiation. This flow does not have a fixed direction inside the disk. It is formed dynamically, responding to the slightest changes in density and magnetic structure. Closer to the center, the curvature of space becomes so strong that the difference between the trajectory of movement and space itself is gradually erased. The lines of motion of matter cease to be independent of geometry. They become its direct manifestation. In such a region, any change in mass is immediately reflected in the entire structure of the surrounding space, creating the effect of an instantaneous restructuring of the gravitational field at the local level.
Magnetic structures continue to become more complex. They form a layered network in which individual areas of the field are periodically destroyed and restored, releasing energy in the form of powerful pulses. These pulses propagate through the plasma, creating density and temperature waves that can cover large areas of the disk, altering its dynamic equilibrium. Relativistic jets coming out of the polar regions retain their stability due to their deep connection with the rotation of the central object. They are narrow channels through which energy and particles are removed from the system. As they move away from the center, their interaction with the intergalactic medium leads to the formation of shock waves that heat the surrounding gas and change its structure over vast distances.
Gas flows feeding the central region continue to flow from the outer regions. These flows are not continuous in the classical sense. They consist of fragments of different densities, which are gradually stretched and accelerated, falling into the gravitational field. As they approach the disk, they lose their original structure and are included in the general accretion dynamics. In the region of the photon sphere, light trajectories become so warped that they can repeatedly wrap around the central mass before escaping into open space or disappearing behind the event horizon. These complex orbits form a unique zone where the behavior of radiation is determined solely by the curvature of space and not by the source of light. The event horizon continues to be the boundary beyond which all processes become inaccessible to external observation. Anything that crosses this area ceases to participate in further information exchange with the outer universe. However, the space around this boundary itself remains dynamic and actively interacts with the environment through gravitational and energy effects. Over time, the system does not lose intensity. On the contrary, its internal processes continue to maintain a high level of activity due to a constant influx of matter and energy. Even when environmental conditions change, the quasar retains the ability to emit powerful radiation, adjusting the balance between energy absorption and release. And in this continuous evolution, there remains only one unchanging state: the constant movement of matter and energy towards the center, where the very structure of reality takes on a form that goes beyond the usual description, remaining hidden behind the event horizon, in the depths of the gravitational field that defines the entire system. And ultimately, this entire giant system around TON 618 continues to exist as a single, continuously pulsating mechanism on a cosmic scale. Matter comes from distant regions, crosses billions of kilometers of space, breaks up into streams, filaments, and clouds, and still inevitably returns to the center, where gravity becomes the absolute dominant. The accretion disk, which has survived countless cycles of heating and reconstruction, remains stable only due to constant motion. There is no state of rest in it. Any moment of equilibrium is immediately disturbed by a new influx of matter or a flash of energy. And it is in this eternal imbalance that its power is born, turning the gravitational fall into a luminosity that surpasses entire galaxies.
Relativistic jets go further and further into intergalactic space, leaving behind traces of shock waves and energy disturbances. They become the connecting threads between the central source and distant regions of space, spreading an influence that is felt on scales unattainable by conventional star systems. Even where the structure of the galaxy itself is already decaying into rarefied gas, these streams continue to retain their shape and direction.
Over time, the influx of matter may weaken, and the activity of the quasar gradually decreases. The disk becomes less dense, radiation becomes less bright, and internal processes become less violent. But even in this decaying state, the central object remains a colossal gravitational center, capable of holding space around it in a curved form. The event horizon remains the last boundary beyond which any possibility of external interaction disappears. Everything that crosses it becomes part of the internal structure, inaccessible to observation and description through external signals. And it is this boundary that completes the entire system, not as a wall, but as a transition to the realm where the concepts of time, motion, and information cease to have their usual meaning. And when the external radiation gradually weakens and the accretion disk loses its former brightness, only a giant, dark mass remains, continuing to curve the space around it. It no longer shines as a quasar, but continues to exist as one of the most massive objects in the universe, keeping traces of an era when matter and energy were in a state of extreme cosmic activity. And in this silence, which comes after billions of years of rage, only the structure of gravity remains, slowly but inexorably holding the surrounding space in shape, given by the once colossal growth process that once turned an ordinary accumulation of matter into one of the most extreme objects in the cosmos. But even then, TON 618 does not disappear from space. Its gravity continues to hold huge regions of space around it, preserving traces of ancient activity when the quasar's core illuminated the surrounding darkness with streams of energy. Where relativistic jets once raged and incandescent plasma rotated at extreme speeds, there remains a gigantic region of curved space in which the motion of matter is still subordinated to an invisible center. The remnants of radiation slowly fade away. Gas clouds are gradually dissipating. Shock waves dissolve in the intergalactic medium. The space around it becomes colder and darker, but the black hole itself continues to exist, retaining the monstrous mass accumulated over eons of continuous absorption of matter. And even after billions of years, the influence of the ancient giant will still be felt around it. The orbits of distant star clusters will remain curved. Light passing nearby will still change direction under the influence of gravity. And behind the event horizon, there will forever remain a hidden region that is inaccessible to any radiation and any signal from the external universe.
Thus ends the era of one of the most powerful quasars in the cosmos, not with an explosion or disappearance, but with a slow transition into absolute darkness, within which an object whose mass is capable of bending space on scales far beyond the usual understanding of galaxies and black holes continues to exist. And in the midst of the endless cosmic emptiness, only the silent center of gravity remains, around which streams of incandescent matter once rotated, and now only the cold radiation of the distant universe moves, gradually dissolving in the depths of eternal space.